session. We didn't talk at all about fees. I don't know, perhaps you looked on our website.
I did.
The first session is free, this session. And then after that, for online sessions, it's $28 per hour. If it's in person, it's $35 an hour.
Okay.
Okay, and I'm certainly willing to meet you in person if you're more comfortable with that kind of tutoring. But I think after today, you will realize that this is very visual, and this will probably work for you.
Yeah, I think it'll be good.
Okay. It's the Accuplacer exam that you're preparing for. Is that correct?
That's correct. And here's my dilemma.
Okay.
I have to take this math class this fall, or I will not graduate in December like I wanted to. Now, I understand that that may not work, but ideally, I need to take this test and pass it by Monday. And so my hope was to do as much as possible in the next 4 or 5 days.
Okay.
Go take it, and if I fail it, I fail it, and it just doesn't work the way I wanted it to. But if I can pass it with
if you pass the test,
I have to pass it with a 72 or better in order to place into mathematical modes of thought, which is what I need to take.
Okay. Well, we can give it our best shot.
Sure.
Might be asking a lot. I don't know. It really depends on your math skills.
It's asking a lot.
How long's it been since you've taken these kind of?
It's been 15 years because at my high school I didn't have to take math my junior or senior year if I opted out of it, which I did. So it has been 15 years.
Okay. Well, I guess the only thing I can suggest is that we start at the beginning. And hold on 1 second, if you would.
Sure.
I know it sounds like a madhouse around here, but I just saw a spider on the wall.
Uh-oh.
Okay. Good to go now. Shall we just use this Accuplacer exam that I actually got this from Amy last year when she was...
Yeah, that's perfect.
Okay, good. The first section of it is order of operations. Perhaps you remember something called PEMDAS?
Vaguely.
Okay. Let's go through PEMDAS. That's all that these questions are really pertaining to, is the order of operations. Do you know what the P stands for?
Parentheses.
Okay, and the E?
Exponents.
And the M?
Multiplication, division, adding, subtracting.
Okay. So, are there any of these that you're not sure about? We don't really need to cover stuff if you feel comfortable that you know how to do it.
The only one that seems to really confuse me when I'm doing the equations is the parentheses and exponents.
Okay, when you have both. Usually a nice rule of thumb is to always work from the inside out. Okay? In other words, if we look at question number 4 here, that looks like it might be kind of confusing.
Yes.
We're going to do the furthest inside is 6 minus 12. So we're going to do that first.
Okay.
Okay. That becomes minus 6, which we're going to then square, which becomes plus 36. So then you would actually have 4 minus 36. and then you would apply the negative sign to that answer, so the numerator would actually be plus 32.
Because it's a negative and a negative.
Yes, exactly. In other words, the 6 minus 12 becomes, hold on, I'm going to lower this just enough. So we end up, if we do this step by step, we have 4 minus a negative 6 squared. We do this step next, so it now becomes minus 4 minus 36. Now it becomes minus 32. And now the minuses become plus, and it just becomes plus 32.
Okay.
Okay? Let's look at the difference between 1 and 3 here. You'll notice that 1 has the negative 4 in parentheses. So when we square negative 4, we're going to get positive 16. Notice the difference between this and problem number 3. It's negative 3 squared, but the negative 3 is not enclosed in parentheses. So this square would only apply to the number, not the sign. So this actually would be 3 squared, which would be 9, and you would retain the negative sign. So it would still be minus 9.
Okay, so go back to number 1, and so that's a positive 16?
Yes. Yeah, I tell you what.
And why? And so
let's go through these and just work through them. It's probably better than trying to explain my reasoning. Okay, so number 1, let's simplify that. Go ahead and start reducing it and tell me what the new numerator is going to be. In other words, what is this going to equal?
okay, so this may sound really stupid, but 2 cubed, right? That's what that is with 3. So then, is it 4? Is it 4 times?
It's going to be 2 times 2 times 2. So
8?
yes. So this would be 16 plus 8. Can you excuse me for just a second? Let me bring my dog in. I can stop that dog.
Go ahead. Go ahead.
Hi. Come here. Hi. Okay. Sorry about that.
That's okay.
Okay. And so that's 24 in the numerator. Now what do we have in the denominator?
4. But I guess where I'm getting confused is why did we lose the negative in the parentheses?
We don't.
Okay.
In other words, this negative 2 cubed is minus 2 times minus 2 times minus 2, which is equal to negative 8.
Okay, I see where, okay.
Okay, so this denominator now becomes negative 8 minus 4, which is what?
Negative 12.
Okay, so now we have 24 divided by negative 12. There's our answer.
Okay.
All right.
Okay.
Let's do this one without writing. So we have 17 minus
minus 9
plus 13. So that's going to be 21.
Right.
divided by
16 minus 9.
Okay, so that's 21 divided by 7. That would be 3.
3. Okay.
And let me know if I get this too small for you to see.
Okay.
Sometimes it's hard for me to make room on my computer screen to get everything I need on there. Hold on one moment. Okay. So what's the next step on number 3?
I'm sorry, what?
So what's the
next
first
step
step?
on number? I guess simplifying everything.
Okay. So what would I start with?
Multiplying the parentheses is where I would start. I don't know if that's right or not.
Okay, well, if we follow PEMDAS, we're going to do whatever's in the parentheses first. Rather than multiplying this 2 times the minus 5, let's do this minus 5 plus 3 first.
Okay, so positive or negative 2.
Okay. And that's over, how about the denominator? What's the denominator?
Negative 4.
Okay. And then we're going to subtract. What are we going to do up here?
The parentheses, so negative 9 plus 2 would be 11.
Negative 9 plus 2.
Negative 9 plus 2 would be negative 7, sorry.
Okay, that's okay. And the bottom?
I don't know.
3 minus a negative 1/2 becomes, in other words, these 2 minuses become a plus, and we end up with just 3.5.
Okay.
Okay, so now that becomes 1 minus,
why is that becoming 1?
2 times negative 2 is negative 4, and negative 4 divided by negative 4 is equal to 1.
Okay.
Okay, and let's do this step by step. The top is minus 21. The bottom, let's change to an improper fraction of 7/2. Now, how do we do that?
To be honest with you, I don't even know how you got the 7/2.
Okay, I changed the 3.5 into 7/2. In other words, 3.5, 3 is the same as 6/2 plus 1/2 gives us 7/2. Okay. So now once I get this, the reason I changed it to an improper fraction was so that I could conduct this division. It's hard to divide 21 by 3.5. Hi? Come here. Come here. Come here. All right. So to divide a number by a fraction, let's say I ask you to do this. Divide 1/4 or 1/3 by 1/4. How would you do that?
I have no idea.
Okay. We turn it into a multiplication problem. In other words, we flip the denominator and we multiply. So 1/3 divided by 1/4 is the same as 1/3 times 4/1. And then when you're multiplying fractions, you multiply numerators, you multiply multiply denominators, with that.
So why don't you flip the first one? Why do you only flip the second one?
The bottom, that's just the way division works.
Okay.
Only flip the denominator. Okay, so
But,
to conduct this, it's the same as minus 21 times 2/7. Okay, do you see that?
yeah.
Okay, now is minus 42 divided by 7, which is equal to minus 6. The easier way to do this would actually be to divide top and bottom by 7. So I cancel out that 7 and turn that into a negative 3. So now it's negative 3 times 2 equals minus 6.
Okay.
So now the problem becomes 1 minus minus 6, which is equal to
1 minus 6. So negative 5.
these two negative signs turn into a plus. In other words,
Okay, so it's not just in multiplication that they're turning into a plus. So with negative and positive, with adding and subtracting, the rule still stays the same. It's not just multiplication.
Yes.
Okay,
let's just go through a few examples. Give me the answers to these.
2.
Minus 2. It's minus because we're subtracting a bigger number from a smaller number.
Right.
5 minus 3 is equal to positive 2.
Right.
Okay. All right. How about minus 7 minus a 9?
Negative 16.
Okay. About minus 5 times 4.
Negative 20.
About minus 5 times a minus 2.
Positive 10.
Okay. The only difference then is that one where we have a negative and another negative. See, when we
I don't know why I was thinking that the double positive and double negatives only applied in multiplication. I didn't realize that they applied when you're subtracting.
They do apply to addition also.
Okay.
Okay. Let's look at, tell me what processes I'm going to do first for number 4.
The 6 minus 12.
Okay. And then what about in the bottom?
9 divided by 3.
Okay. And then after we do that, what are we going to do?
On the bottom, I would do on the bottom, 3 plus 4.
Okay.
And then square it.
Okay. So that would be 7 squared plus 2 squared. Okay. Let's make sure you can do this full numerator because this involves the negative sign. I guess we did that one already. Let's go to 5. Okay, do you know what these two signs, these bars mean?
I don't.
That's absolute value. Okay, and as all absolute value means is whatever number results from this, you take the positive result, even if it's negative.
Okay.
Okay, so this number would be, first of all, what's minus 2 minus 3?
Negative 5.
Okay, so we're going to take just 5 out of that. And that's what our new number is going to be. What is negative 6, negative 3?
Negative 9, so 9. Or no, because it's not.
That's not inside absolute value.
Okay.
So now it's negative 9 times 5, which is negative 45.
Okay.
Okay. Let's look at number 6.
Okay.
Okay, we got two strange parts. We got this part. We got this part over here.
Right.
They're being added. So which one goes? Which one gets done first?
The one on the right because it's got parentheses.
Okay, or the one on the left because it's got division. The P for PEMDAS, the parentheses, really means more if there's a process going on inside the parentheses, that's what you want to do first. In this case, there's nothing going on inside. So all this parenthesis means is multiplication.
Okay.
Okay, so, but PEMDAS, multiplication, becomes in front of division, so let's do the multiplication first.
Okay, so you multiply the top and the bottom. Is that correct? So it would be 3 over 15.
Negative, because we have a negative there and a positive.
Right.
So it'd be negative 3 over 15. We can worry about reducing that later. Put parentheses around it. What about the 3/7 divided by 8/7?
So is this, do you flip it? Okay, so it's 3/7 divided by 7/8?
Actually, times.
Times
When you flip it, you have to change it from division to multiplication. In a very similar way that when I do -7 minus 9, if I want to take this is a subtraction problem. That's what this negative sign means, is subtract. Well, I can turn this into an addition problem by making it an addition and then changing the sign on whatever is being subtracted. So this actually becomes -7 plus a -9. Well, that's the same thing we're doing when we take this division problem and turn it into a multiplication problem. Is we're 3/7, instead of dividing, we're going to multiply, and since I'm doing that, I have to flip that.
Okay, so that becomes 21 over 56?
Let's do it easier. You always want to use as small numbers as possible, whether you're using a calculator or not. Doesn't really matter. I can say that this is 21 over 56. Notice how much easier it is if I divide top and bottom by 7. I can divide that by 7, leaving behind a 1. And I can divide that by 7, leaving behind a 1. So now I have a real easy problem with 3/8.
Okay.
And I never had to use a number bigger than 8.
Okay.
Okay. So that's what 3/7.
Now it becomes 3. Go ahead.
Yeah, that's what 3/7 divided by 8/7 becomes 3/8.
Okay.
So now I'm going to take the 3/8 and I'm going to add it to this negative 3/15. Let's simplify the negative 3/15 first.
1 over 5.
Okay. Now, since I'm adding a negative number, I can rewrite this whole thing as 3/8 minus 1 over 5.
Okay.
Now, how do we do this?
Do you do it straight across to where it would be 2/3?
When you're adding or subtracting fractions, you have to find a common denominator. It's actually harder to add and subtract fractions than it is multiplying and dividing. When we multiply two fractions, we just multiply the two tops and the two bottoms. But when we're adding or subtracting, we can only add stuff that has the same denominator.
Okay.
Okay. So how do we find the lowest common denominator when we're looking at two fractions like this?
Whatever divides into both of them equally, the lowest number.
Well, one thing we could do is, for sure, 40 is going to be a common denominator, because
Okay.
it's just the product of 8 times 5. So we know that 8 divides into it and 5 divides into it. There could be a smaller one that might represent the lowest common denominator, but in this particular case, there isn't. The way you find the least common denominator is you start with the biggest one, 8, and you start increasing it by multiples of 8.
Right.
None of these are divisible by 5 yet,
Right.
until I reach 40.
Right.
So now I have a common denominator. So if I want to use a common denominator of 40, what do these two fractions turn into? How many 40ths is 3/8?
I'm not sure that I understand.
Okay. What we have to do is turn this fraction into some number of 40ths.
Okay.
And I can do that by multiplying the top and the bottom by 5. In other words, you can multiply any fraction by 1 without changing its value. So
Okay.
if I multiply 3/8 by 5 over 5, it becomes 15 over 40. So
Okay.
3/8 converts to 15 40ths. How do I convert the 1/5 into some number of 40ths?
Times it by 8.
Right, 8 over 8. So 1/5 becomes 8 40ths.
Okay.
Now, because I have the same common denominator, I can act on the numerators, and the answer becomes 7 40ths. So the common denominator just carries forth, and you do whatever the numerator calls for.
Okay.
Okay?
Okay.
All right. Let's go on. Let's see. Let's make sure you know what some of these mean. You know what that means?
Is that the square root of -8 cubed?
It's the cube root of -8.
Okay.
Okay? And that's going to be equal to -2. The reason being is that if I cube -2, I get -8. Therefore, the cube root of -8 has to be -2.
Okay.
Okay? Now, if I add a 5 in front of it like that, that does not mean 5 cubed times the square root of -8. This
Okay.
is what takes precedence. So we've already decided that's -2, so now it's merely 5 times a -2. So this whole bottom part here becomes -10.
Okay.
Okay, so let me write that. So we have 6 minus a -10.
Okay.
Okay, let's look at the numerator. What's this term on the left going to be?
-5 times 9.
Okay, so that's -45
Right.
plus what?
Plus 9 times the square root of 4.
And what's the square root of 4?
16.
No. To get a square root, we're looking for a number that, when multiplied by itself, equals 4.
2.
Right. Okay, so this is 9 times 2 minus 5. Okay, now since the numerator is merely a bunch of addition and subtraction, well, we can replace this with 18. So the numerator becomes minus 45 plus 18 minus 5. What does all that equal to?
I don't know. I can't do math that quick.
Okay, it's minus 50 plus 18. In other words, I combine these two first. Become minus 50 plus 18 gives us minus 32. So there's the numerator.
Okay.
What's the denominator? What's that equal to?
Is it 16 because the two negatives become a positive?
Yes. So this whole answer becomes minus 2.
Okay, because we're dividing the 16 divided by the 32, and that's an, okay.
Yes. Okay, let's look at number 8. So let's focus. It's 24 times the quantity minus 3/7 divided by 5 and 1/7. Okay, so how do we do what's inside the parentheses?
You're going to multiply it by switching the numerator and the denominator at the 1/7.
Well, we can't work with just the 1/7.
Right.
In other words, I can't multiply it by 5 and 7/1.
Okay.
I have to convert this whole thing to an improper fraction. Right now it's a proper fraction.
Right.
Okay. So what would that be as an improper fraction? In other words, if I want to represent that as some number of sevenths.
I've already forgotten how to do that. I'm not sure.
Okay, well, we take the 5. How many sevenths is 5?
I don't know.
Okay. And the way I get that is I take the number 7, and I take the number 5, and I multiply it by 7 divided by 7. This concept of being able to multiply any number by 1 without changing its value is very big in math. Okay? So to convert 5 to some number of sevenths, I multiply it by 7 over 7, and I get 35 over 7.
Okay.
Now, I still have this 1/7. So how many sevenths do I have in total?
36?
Right. So 5 and 1/7 becomes 36 over 7. Now I can do my little trick of flipping this and multiplying. Okay, so let's change this to multiplication first of all. And then let's flip this into 736.
Okay.
Okay, now what am I going to do?
So you multiply across and get negative 21?
There's an easier way to do this. Let's try to reduce this before we multiply it out.
Okay, so then you end up with negative 336.
Right, because the 7's cancel.
Right.
So I end up with negative 3 over 36. That also reduces.
Okay, into 12.
1 over 12. In other words,
1 over 12.
just like multiplying any number by 1, I can divide top and bottom by 3. And that produces negative 1 over 12.
Okay.
Now I can reduce it even further. What can I do with my 24 and 12?
You're multiplying those, right?
Well, actually I would be multiplying the tops, so it would become minus 24 over 12. What does that reduce to?
1/2.
I'm going to divide top and bottom by 12 rather. So it leaves my 2 in the numerator and the 1 in the denominator. Gosh, are all these answers minus 2? Seems like a lot of them are minus 2. Hold on. I'm sorry, I just got this dog. I haven't had to figure out how to deal with this problem yet. 1 second.
No, you're fine.
I'll try shutting her outside. Maybe at least we won't hear it. Yeah. All right, let's go on. All right, let's look at some of these things here. What is a fractional exponent? What does it mean for me to write this?
I'm not positive. First, I feel like part of me remembers you having to multiply the 2 times the 4 and then the 3 times the 4, but I'm not sure.
Okay. The bottom number means take the root, and the top number means cube it. So when I write 4 to the 3/2 power, I have a choice. I can cube 4 first, which gives me 64. And then I'm going to take the square root of 64, which gives me 8. Or I have another choice, which is usually the better one, which is to take the square root first and then cube it. Notice that the square root of 4 is 2, so it becomes 2 cubed. So I get to my same 8, but notice I didn't have to deal with the big number 64. In other words, by taking the square root first, it made the problem simpler. But that's what that means. Okay. Let's test you. What is So what does the 3 mean?
I'm not sure. Can you go through that whole thing with me one more time, please?
Sure.
A lot of that went right over the top of my head.
The denominator means the root. So we're going to take the cube root of 64, and that is 4, because 4 times 4 times 4 equals 64.
Okay.
And then we're going to take that to the 4th power because of this.
Okay. So 16?
Yeah, so essentially when I have 64 to the 4/3 power, I can write it like this. Cube root of 64 taken to the 4th power. Well, let's make it a little easier. Let's make that a 2. Well, if the cube root of 64 is 4 squared, that becomes 16. So the answer to that is 16. But notice that it can be, if I were to square 64 first, I would have a big number, which I would then have to take the cube root of. Much harder to get to the answer.
Right.
But if I take the cube root first, the problem becomes much easier.
Okay.
Okay. So let's go through this process here. Now, notice that the 3/2 is the very outside of these brackets. So that's the last thing we're going to do. We're going to do everything inside. We've got a parenthesis, we've got another bracket, and then we've got an outside bracket. But we have a bunch of nested parentheses. So whenever you have nested parentheses, you start from the inside and go out. Okay.
Okay.
So let's start. What's the very inside thing I'm going to do?
10 minus 8.
No, we're going to go to the very inside parenthesis.
Okay, so 6 divided by 2.
Okay, so that's 3.
3.
So I'm going to replace that with a 3, and I still have these brackets. Notice that that 2 comes after the bracket, so that's being squared.
Okay.
Then I have another bracket that's being taken to the 3/2. So now what's the next step for me?
4 minus 9.
4 minus 3. This is a 3,
Okay.
because 6 divided by 2 is equal to 3.
I
So,
was squaring it only.
okay, so I'll take this 4 minus 3 and replace it with a 1. And what's the next thing I want to do?
Square it.
Right. In other words, I'm going to square it before I multiply it by 8. Because this 8 is not being acted upon by this squaring. Only the 1 is.
Okay.
So this now becomes 10 minus, well, 1 squared is what?
2.
Actually, it's 1. 1 times 1.
Okay.
Okay, so I'm going to replace this whole thing with a 1. And I'm going to leave it in parentheses only because it's being multiplied by the 8. So now I multiply 8 by the 1. So now I'm almost there. So now I do this. 10 minus 8 is 2. So I'm taking 2 to the 3/2 power.
Okay.
Now, in this particular case, I can't take the square root of 2 and get a nice even number. So I'm going to cube this one first, and then take the square root of that. So this is going to be equal to 8, the square root of 8.
Okay.
Which is an answer.
Okay. This is all like
This is all like haven't
done
this in a long time.
Yeah, it's a lot of
Okay.
information.
Okay, it is. I know it is. Shall we go on, or do you have some questions that you want to ask about any of this?
I think going on is fine because right now it's all overwhelming.
Okay. Well, here's one nice thing about having the recorded sessions. Is you're going to get a file that you can play that will repeat all of this. And you'll be able to pause it, rewind it, fast forward it. So all of this stuff that we're reviewing, you're going to get another chance to hear it. So
I feel like like I almost need to like start back, like way back in practicing square roots and practicing multiplying fractions.
That's fine.
In order to be able to do this step by step as quickly as you are, because some of these simple steps like square rooting aren't coming quickly for me.
Okay, let's talk about that.
Okay, let's talk about it.
There's some things that it's really going to be helpful if you know.
Right.
2 squared is equal to what?
2 squared is equal to what?
4.
2 cubed.
2 cubed.
16.
2 to the 4th.
2 to the 4th.
I don't know. My math isn't that quick.
32.
32.
These are worth memorizing, and I'll explain in a moment. What's 3 squared?
What's 3 squared?
9.
What's 3 cubed?
What's 3 cubed?
18.
3 times 9,
3
27.
times 9, 27.
Okay.
Okay? You don't need to go all the way up. I don't need to know what 3 to the 4th is. Okay? But you need to know the small numbers, just the first few. What's 4 squared?
What's 4 squared?
16.
What's 4 cubed?
What's 4 cubed?
4 times 16.
4 times 16.
Okay. Again, unfortunately, my math isn't that quick.
No problem. And 2 to the 5th
2 to the 5th
is also 60.
also 60.
Okay? These basics that I've written on the page are worth memorizing. And it's not so much that you need to know what 4 cubed is, it's that you need to know the cube root of 64. Or you need to know the cube root of 27. Or the square root of 9. Let's go through some common squares. You need to know what every single digit square. So that's equal to 4. That's equal to 9. That's equal to 16. What's 5 squared?
25.
And 6 squared?
36.
7 squared?
49.
8 squared?
64.
And 9 squared.
What is that, 72?
81.
81.
So if I ask you what is the square root of 49, what is it?
7.
Right. So that's why it's worth memorizing, is so that when you have to go backwards, you'll be able to do it. The square root of 81 is 9. You don't want to have to use a calculator to figure out the square root of 64. You want to have that in your memory database. And some of the common cubes, just the ones I wrote, not any others. In other words, if you know what this one is, this one is, and this one is, then you'll know cube roots. And maybe one other would be 5 cubed is 125. Occasionally you're going to run across a problem that asks you for the cube root of 125. They're never going to ask you for the cube root of 126. Not unless they want you to give them a calculator answer. If you have to be able to do these without a calculator, then they're always going to give you numbers that give you nice, even results.
Okay.
Okay? All right. So that's...
So I think that for me, a lot of it is just terminology, remembering, cube and cube root and square root and all of that. That's where I'm getting a little hung up.
Okay, that's fine. We'll keep repeating that as we go on. So I think that you'll pick that up even if you don't remember it now. We'll come across problems where you'll get reminded of it again.
Okay.
All right. Let's try going through some of these problems. In all honesty, what you see here in these first 10 questions, you're not going to have to do that. You might have to do some of it in some algebra problems, but it's unlikely you're going to have to do something like this, number 9.
Yeah, when I took the Accuplacer yesterday, I did not see anything like number 9 on it.
Okay. Let's go to substitution. Algebra. So we have the expression. Do you hear that echo, incidentally? Or am I the only one that hears that?
I don't.
Good. Thank goodness.
Yeah, I don't hear an echo.
It's driving me crazy, but I can. The worst thing that might happen is I might talk a little bit louder because I'm kind of having to overcome the echo that I hear. But I'll try not to.
Okay.
So we have y squared minus 3x. How do we evaluate this when x is equal to minus 3 and y is equal to minus 5?
So you substitute those in. So it would be 5 squared minus 3 times negative 3, correct?
Okay, it would be minus 5 squared.
Yeah.
So I would do it like that. Minus 3 times a minus 3. And now you're left with what we just went through. So what's the answer to this one?
So is it negative 25 minus, or
Okay,
plus
what's
9?
minus 5 squared?
What's minus 5 squared?
Mm-hmm.
So
You have a minus 5 times a minus 5.
okay, so positive 25.
Right. Okay, so I'll replace that with a 25. And then what's the rest of it?
Negative 3 times negative 3. So is it a positive 9?
It is a positive 9, but let's just talk for a moment about the difference between that negative and that negative. This negative is a negative sign. This negative is subtraction. Okay, so let's leave it as a subtraction problem. And then 3, positive 3 times negative 3 is minus 9. So we do end up with the two negatives. So that the answer is that. But I just would like to make that distinction between negative signs and subtraction.
Okay.
A lot of people get confused by the negative sign because they're frequently unable to tell whether it means subtraction or whether it means a negative sign. You interpreted that as being a negative 3, but in reality we're subtracting. So, and we're subtracting a positive 3 times the negative 3.
Okay, that's good to know. I'm glad you clarified that.
Okay. Let's do another one here. Okay, we have y plus 2z divided by 5y minus xz. And we want to evaluate it when x is equal to minus 5, y is equal to minus 2, z is equal to 3. So help me rewrite that with substitution.
Okay, so negative 2 plus 2 times 3. And then 5 times negative 2 minus negative 5 times 2.
So in all of these, we end up with problems that look very much like what we just did. Okay, so what's the numerator become?
Negative 12?
Okay, we have a -2 plus a 6.
Right. Oh,
Okay.
why am I multiplying that?
When we're adding a negative number to a positive number, we subtract the two numbers and we put the sign on it of the largest number. So
Right, so it
I'm
becomes
going to
4.
take 6 minus 2, which gives me 4, and I'm going to put a positive on it because the 6 is positive. So
Okay.
positive 4 in the numerator. What's the denominator become? What's that?
Okay, so on the bottom when you're doing this,
Mm-hmm.
on the, I know that the first one is negative 10, and then it
Okay.
becomes minus.
That's still
So now
subtraction.
on this, it is, okay. So then it's negative 10.
Like that.
So then it's negative 10 minus negative 10 would be negative 20.
Actually, negative 10 minus a negative 10, these two negatives become a positive, so I can replace both negatives with one positive, and it becomes 0.
Okay, so this switching back and forth between negatives, staying negatives, and not, that's good.
Let me give you a trick for handling subtraction. Let's do subtraction the same way we do division. Every time we're going to have a subtraction problem, we're going to turn it into an addition problem. If I want to subtract that, I'm going to turn it into an addition problem by changing that to an addition and then changing the sign on what was being subtraction. So this just becomes 6 plus 10, 16. If I am adding a positive and a negative number, what's this?
Negative 3?
Right. In other words, I subtract the two numbers, put the sign on it of the larger number. Okay. Now, it's interesting what they did here. I don't know if you realized that we ended up with 4 divided by 0.
Right.
What's the answer to that? What is 4 divided by 0? No. First commandment in mathematics, thou shalt not divide by 0.
Okay.
Okay? First and only commandment, probably. I've read a lot of funny commandments of mathematics, and every one of them starts out with thou shalt not divide by 0.
Okay.
4 divided by 0 doesn't exist. Actually equal to infinity.
Okay.
Okay, but you can't do it. And that's what I found interesting, is they gave us a problem that had 0 in the denominator.
Okay. So you can't do it, so then it just stays with 4?
They didn't give us a problem that had 0 in the denominator. 4 was our numerator, but let's look at our denominator again. 5 times negative 2 is minus 10, but then x was minus 5 times 3, so it's actually a negative 15, not a negative 10. So this actually ended up being 4 over 5. That was the answer, not this. We didn't substitute right. The first time through, I think we substituted a negative 2 for z, and we needed to substitute a positive 3.
That's what I did on mine.
Okay, I wrote it down wrong then. When I was first doing it, I had it written down, and I erased it.
Okay.
Okay.
I think that if this is if this is the same test that's on currently, the solutions to these are on there. So between
Yes.
now and our next session, I can
Okay.
go
They're at
through
the
and do
very
them all,
bottom.
and hopefully we'll.
Here's all of the
Yeah.
solutions.
Okay.
Here's all the solutions.
What problem was that? That was
What problem was that? That was
4/5. That was number 12.
4/5. That was number 12.
Yeah.
Remember the other problem we had was the
The other
square
problem
root of
we had
8,
was the square root of
which is the same as 2 times the square root of 2.
times the square root of 2.
Let's talk about
Yeah.
that just
Talk
briefly.
about that just briefly.
How we simplify things like this.
Things like this.
That's equal to the square root of 4 times 2.
4 times 2.
And that's equal to the square root of 4 times the square root of 2. Square root of 4 is 2.
Square root of 4 is 2.
So that's how I do that.
So that's how I do that.
Okay.
Okay? Whenever you have a square root of a number that you're trying to simplify, and that is something you're going to have to do, because they want it in simplified. In other words, square root of 8 wasn't the answer. The answer was 2 times the square root of 2.
Times the square root of 2.
Okay.
Okay? All right. Why don't we stop for that now, and let's just have a quick look forward here. In other words, this section on substitution, after we've substituted, it becomes the same exact kind of problems as 1 through 10, just simplifying it.
Okay, so between now and the next time I see you, what are the best things for me to be working on?
I would say make sure that you can do the rest. Do you have this exact test?
I know that there's one online. I just don't know if it's exactly this one. I hope it is, but I don't know for sure.
Let me email this to you.
Okay.
I can do that. And let's see, the email I should use for you is this one
A
here?
moment in NTM.
Yeah, at Gmail. Okay. I have your email. I will send you this test, and probably the best thing for us to do is we won't go through each of these when we have a session. We'll go through maybe half of each section and then let you do the others. In other words, we would do, say, 11 and 12, and then you should be able to do 13 and 14.
Okay.
And then next time we get together, we'll go to the next section of simplifying expressions. And that way we might have a chance, because quite honestly, if we have to go through every single problem that's on this test, we're probably looking at about 16 hours worth of sessions. So if we can kind of go through them where I show you how to do this one, and you can figure out how to do the others that are similar. And what I'll do is show you the unusual ones that have something different about them. And then you'll have some that you can practice doing on your own.
Okay.
Okay? So I will email this to you. I will also email you the link to this recording of this first session.
Okay.
And we have another session scheduled for tomorrow night at 7.
Yeah, and then I scheduled one for Friday first thing, which doesn't really make a lot of sense since we're going to end on Thursday night. So I think I'm going to switch that to either later in the day, or if there's appointments on Saturday, I'm not sure.
I'm completely open on Saturday. I can move it for you right now if you want. I can probably do it.
Yeah, let's do that. Yeah, let's move it to like 10:30 on Saturday.
Okay. Done.
Yay.
Like I said, I can do it a lot easier. Okay, so I will see you tomorrow. I will talk to you tomorrow night at 7. And
Okay.
yeah, I would say that make sure you can do these first 17 problems on this test.
On simplifying. Okay, first 17 on simplifying expressions.
Yeah, the order of operations, the substitution, and that's all. And then we'll start with simplifying expressions tomorrow night.
Okay.
Or we'll start with any questions you might have. If you can't figure out how to do these on your own, then we need to go over those.
Okay. So the rules that I have written down are the PEMDAS, the lowest common denominators, and absolute value. Is there anything else when I'm doing those other specific rules I need to be remembering?
I don't think so. We've gone over all 10 of these. So the only problem is going to be when you go to substitute 13 through 17 as to whether you can simplify those or not. In other words, once you substitute, as long as you can simplify these, the answers are at the back, so you can actually check your answers.
Okay.
Let's do one last one before we leave here. What's 14?
Let's see. I'm confused by that one because it's a negative x when x equals -1.
So it's negative, and in place of x, I'm going to put -1. Still have the
that
cube.
becomes a positive 1, right?
Well, not yet. It doesn't. First of all, we have to apply this. In other words, you can't do this whole process in one step. You have to do the exponential first. And -1 cubed is -1. Because -1 times -1 times -1. Then we still have that. So that's equal to 1.
Okay.
Okay.
Okay, that makes sense.
Okay. So let's go with that plan, and I will. So what I will do tomorrow night is text you meeting ID number, and you don't need to go to that site again. If you look on your desktop, you should have an icon that looks kind of like this GoToMeeting icon right here.
Yep, I do.
If you double-click that, it starts out by asking you for a meeting ID number. And I will just text that to you a few minutes ahead of 7 o'clock.
Okay.
So you can just go ahead and join the meeting on your own. It won't require a phone call.
Okay.
Before every session. Okay?
Sounds good. I will be ready.
Okay.
Alrighty. Thank you so much.
I will talk to you tomorrow, Tara.
All right. Have a good day.
You too. Bye-bye.